All right, let's talk about another type of non-linear graph. In other words, it doesn't graph as a straight line. In this case, parabolas. They're things that have x squared in them. So the highest index is 2. So if I have a look here, you'll see this x squared. The highest index value is 2. We also call them quadratic equations. Now, why quadratic? Well, if you think about it, x squared, a square is a quadrilateral, has 4 sides. There's a bit of a relationship there. All right, what about though if I had y equals 2x squared? Now you can see that this graphs as a bit of a tighter curve. It's like steeper. So if as the number in front of the x squared, or the coefficient of x squared, gets larger, the graph kind of gets tighter. It kind of squeezes up, and vice versa. If you had half x squared, it would start to get wider. All right, that's one variation. What about this one? If my coefficient of x squared was negative, the parabola will be upside down. Okay, we'll sort of have a curve at the top. We could have something like this: y equals x squared plus 1. You'll see all it's done is it's taken the x squared parabola and moved it up 1 along the y-axis. That's where the plus 1 comes from. It's x squared plus 1, so the y value is plus 1, it just moves up a bit. Or you could go the other way. You could have y equals x squared minus 1, and you'll see that it is now come down to negative 1 as the y-intercept. So the parabolas can move around a little bit based on what else is going on in the quadratic equation. The bottom point of the quadratic, or where it changes direction, we call a turning point. In this case, because it's a quadratic that it sort of goes up and down, like sort of, curves with a bottom, we call that a minimum. Okay, it has a turning point. It also has a minimum value. That's as low as the y value gets. We're talking about the y value in this case. You'll see some parabolas, like this one, if it was upside down, so in other words, it has a negative coefficient, then the turning point becomes maximum. If you imagine it's a graph like a hill, the maximum value is at the top of that hill. So turning points could be minimums. They could also be maximums. It has a y-intercept, and it'll only have one. Okay, any parabola can only cut the y-axis at one point. However, the x-intercepts, and you can see in this example, there are actually two x-intercepts at -1 and 1. So there are two values that will make this equation true. So there might be more than one. There could be two. There can't be any more than two. There could be one. If you think back to y equals x squared, where it only just touches the x-axis, then there's only one x-intercept, or there might be none. We had a parabola y equals x squared plus 1 that was moved up a bit. It didn't even touch the x-axis. So there might be 2, 1, or none. One last thing we want to talk about with regards to parabolas is that they're symmetrical. So where my turning point is, if I take a vertical line, my parabola will always be symmetrical around that point, which is what we call the axis of symmetry. So in this case, it's actually the y-axis that is the axis of symmetry. That is it for a bit of an intro just to some of the guided tour, I guess, of a parabola and some of the things you should be aware of.